Bone formation and development. In the primary stages of embryonic development, the embryo's skeleton consists of fibrous membranes and hyaline cartilage. The actual process of bone development, also known as ossification or osteogenesis, begins by the 6th or 7th week. There are two osteogenic pathways: intramembranous ossification and endochondral ossification, but bone is the same regardless of the pathways that produces it. Below there is a diagram of endochondral ossification in your long bone.
For skeletal development, the most common template is cartilage. During fetal development, where the bones will be formed is determined. Cartilage is a flexible, semi-solid matrix produced by chondroblasts and consists of hyaluronic acid, chondroitin sulfate, collagen fibers, and water. As the matrix surrounds and isolates chondroblasts, they are called chondrocytes. Unlike most connective tissues, cartilage is avascular, meaning that it has no blood vessels supplying nutrients and removing metabolic waste. All of these functions are carried out by the diffusion through the matrix. This is why damaged cartilage does not repair itself as readily as most tissues do. Throughout fetal development and into childhood growth and development, bone forms on the cartilaginous matrix. Most of the cartilage has been replaced with bone by the time the fetus is born. Additional cartilage is replaced throughout childhood and some remains in the adult skeleton.
Intramembranous ossification and endochondral ossification. Intramembranous ossification. During intramembranous ossification, compact and spongy bone develops directly from sheets of mesenchymal or undifferentiated connective tissue. The flat bones of the face, most of the cranial bones, and the clavicles or collarbones are formed via intramembranous ossification. It begins in utero during fetal development and continues on into adolescence. At birth, the skull and clavicles are not fully ossified, nor are the sutures of the skull closed. This allows the skull and shoulders to deform during passage through the birth canal. The last bones to ossify via intramembranous ossifications are the flat bones of the face, which reach their adult size at the end of adolescent growth spurt. Endochondral ossification. Bone develops by replacing hyaline cartilage. Cartilage does not become bone. Instead, cartilage serves as a template to be completely replaced by new bone. Endochondral ossification takes much longer than intramembranous ossification. Bones at the base of the skull and long bones form via endochondral ossification. By the second or third month of fetal life, bone cell development and ossification inclines and creates the primary ossification center, a region deep in the periosteal collar where ossification begins.
How the bones grow. During the 6 to 8 weeks after conception, the following events occur in the development of long bones. Mesenchymal cells differentiate into chondrocytes, forming a cartilaginous skeletal precursor of the bones. The perichondrium, a membrane that covers the cartilage, starts to appear. These early stages lay the foundation for further bone development and the formation of the primary ossification center. Endochondral ossification simply means the process of bone development that involves the transformation of cartilage into bone. It involves 5 steps, which are: mesenchymal cells differentiate into chondrocytes, the cartilage model of the future bony skeleton and the perichondrium form. Capillaries penetrate cartilage. Perichondrium, membrane that covers cartilage, transforms into periosteum. Periosteal collar develops. Primary ossification center develops. Cartilage and chondrocytes continue to grow at the ends of the bone. Secondary ossification centers develop. Cartilage remains at epiphyseal growth plates, and at joint surface as articular cartilage.
How do bones grow? By skeleton or fossil in a museum, you might think that all bones are dead, but although they are dry, hard or crumbly, the bones in your body are different. They are growing and changing all the time. How do bones grow? Bones will increase in size as you grow older. A baby's body has about 300 bones at birth. These will eventually fuse or grow together to form the 206 bones that adults have. Some of the baby's bones are made entirely of cartilage. This cartilage is soft and flexible. During childhood, as you are growing, the cartilage grows and slowly replaced by the bone. With a little help from calcium, bones replace the cartilage. This is called ossification. During ossification, layers of calcium and phosphate salts accumulate on and encase the cartilage cells. Eventually, the cartilage cells die and leave behind tiny pockets on the bone. Blood vessels grow into these pockets and deposit specialized cells known as osteoclasts, and this helps the bone to grow. Calcium passes into and out of the bone in order to maintain strong bones. While increasing in length, they are also increasing in diameter. This is called modeling, which allows bone to grow in diameter. Low calcium level equals decreased bone density, which increases the risk for bone fractures. The ossification process typically complete by the time a person reaches his or her mid-20s, where their bones are as long as they will ever be.
There is a Q&A on the next two slides that you can do.